This is part 7, talking about David Deutsch's book, The Beginning of Infinity. I wanted to start by revisiting induction because I saw a cool book called Spurious Correlations. And the thing it does is show graphs with correlations between things that do not have a causal relationship. Or if there is one, it's very, very indirect. This raises a question, which is similar to what I was talking about earlier, which is how do you know if a correlation or a pattern is spurious or not? How do you know if it's actually an important one? There are many, many patterns or correlations. Some are important, some are not. This correlation is divorce rate in Maine correlates with per capita consumption of margarine. And it's a very strong correlation, 99.26%. But it's spurious. It is not an important thing about causal reality. It is a coincidence. It's luck. Possibly some really indirect way they're related, but probably just luck that they both happen to be trending down at the same time. And if you look around at all the things that are trending down, you can find some that by chance trended down a similar amount. So induction does not provide a method of figuring out which correlations are spurious or non-spurious, which ones are important. So you need something else, like critical thinking, arguments, intelligence, common sense. You can debate it, you can think about it. And those have to work in a non-inductive way to avoid circularity. And so induction misses the point about how things like intelligence work. It's also worth thinking about the units. So if you change the units for the divorce rate in Maine, you can make the graph look different, and it wouldn't look like as good of a correlation if you kept the same units for butter, if we were going from 2 pounds to 8 pounds. But if the divorce rate went from, say, 0 per 1,000 to 1,000 per 1,000, it would stretch out the red line, but the black line... No, sorry, the opposite. It would condense the red line. If we made the graph go on a much larger range, the red line would basically get condensed and look almost straight, very near the very bottom. If we went from 0 to 1,000 per 1,000, the red line would look kind of like this. Just right near the bottom, we'd have an almost straight line. And if we went up to like 1,000,000 or something, which isn't even possible, like how do you have more than 1 per 1? But anyways, and then the black line would look the same, and then it wouldn't look like a correlation. So changing units can change how these things look. And part of what looking for patterns or correlations is you figure out what units there are correlations in. And trying out many different units is a way to find more patterns, many of which are dumb. There are some attempts to do things in a unit-independent way, to look at something that doesn't depend on which units you're using. But they always make some sort of assumption, and they're never perfect. It's never perfectly unit-independent. For example, not all units are linear. There's log units, like how we measure earthquakes. And you're not going to get unit independence across all types of units. So I wanted to show more of the correlations on this website. Here's a very strong one between spending on science, space, and technology versus suicides by hanging, strangulation, and suffocation. Seems like a coincidence. It might be a very indirect relationship where there's an underlying factor causing both of these partially. And the factor could be something like a wealthier, richer, more advanced society has more spending on science, space, and technology. Well, that makes sense. And would such a society have more suicides? Not necessarily. Like, you can imagine a wonderful, super advanced society where suicide rate has gone to like 0. It's a possible thing. But on the other hand, you can imagine how, in some limited context, a richer, better society could have more suicides. Like, if people are dying of other causes less, if a lot more people are getting old, maybe people get bored after 50 years and start killing themselves. And so a society with better medicine gets more people to the age where they kill themselves. So you can make up some sort of story where they're related, but only indirectly. This is not a good way to figure out what's going on in reality, is to be like, look, there's a strong pattern between these two things. I guess that spending money on science causes suicides. that would be completely wrong. So there are a lot of these. And they're meant to be coincidences, things with no significant relationship between them that would be inappropriate for understanding how the world works. So it would be a bad pattern to look at. And there is apparently a book with more of them. This is just a preview on the website. It seems like enough to get the point. This one looks like very coincidence. Letters in the winning word in a national spelling bee versus number of people killed by venomous spiders. Some of the coincidences are more lucky seeming than others, because some of them it's just like there was a downward trend. Although it's not just a straight line. So there's some, they both sort of went down more and then went down a bit slower. Anyways, ones that go like up and then down and like follow each other on ups and downs, it seems like harder to find that happening randomly. Although it still does happen randomly because a lot of these have nothing to do with each other. This one is a good example of units mattering, because it's about number of letters. In words, it's very arbitrary. Like you could look at the word, you could have number of letters in the word after you translate it to Japanese. And then that would be a different way of measuring the length of the word. And you're going to get different correlations. And if you think about translating it to any possible language, not just languages that exist on Earth, but theoretically possible languages, and then counting the number of letters, or I guess theoretically possible languages that use letters, because I don't think that's all languages. Anyway, so yeah, look at the set of all theoretically possible languages that use letters, then count the number of letters for the closest translation of whatever word it was. And you're going to get different correlations for all those infinitely many different languages. Okay, moving on. So that was a bit more about what's wrong with induction. So the book talks about observation as theory-laden, which means we don't experience direct observations of reality. For example, when we view things, the direct reality is that there are electrical crackles in our brain. That's what our nerves send to our brain. But that's not how we experience or see it. We see it as there is a dog over there. There's a table over there. And the whole concept of over there is an interpretation that we're putting on our observations. So what you want to understand here is examples of interpretations. David talks about a stomach ache or a headache being interpretations, like head and stomach are interpretations about what type of ache it is. That's not something you actually directly observe. It's something that involves thinking, and the thinking could be mistaken. So there's a nice quote, mostly a quote. There's a little non-quote in the middle. But anyways, so Sherlock Holmes said that circumstantial evidence is a very tricky thing. It may seem to point very straight to one thing, but if you shift your own point of view a little, you may find it pointing in an equally uncompromising manner to something entirely different. There's nothing more deceptive than an obvious fact. The point here is that your point of view affects what conclusion the evidence seems to point to. And if you interpret the same evidence in a different way, you can end up reaching a different conclusion. So your point of view affects how evidence appears to point or what conclusions you reach or whatever. So David moves on to a question he asked earlier. How do we know? He's been talking about some things that don't work and some of the difficulties of understanding reality and observing reality and learning things and so on. And there's a question of what does work. But then he says he's going to go on more tangents. He's not ready to present the answer to us. He also clarifies that he's not asking by what authority do we derive or build our knowledge. The question is just actually, what are we doing? What process is it? Like, what physical things happen? What stuff like that. He wants to know what's going on there, not how we justify that our learning works, just how does it actually work? So he starts talking about, historically, people have tried to learn and failed over and over. That's been very, very common. He also talks about more of the difficulty again. We have this ability to learn about things that we have not observed. We can make predictions about the future, even though we cannot measure the future. So our ability to learn and understand things has some sort of disconnect from measurement and observation. We can make predictions about the future, about new things, like will this new design of microchip work, even though we've never observed that microchip and never tried it out before. So people have failed to know lots of things, like poor understanding of the stars. And they've done that with the same sorts of eyes and brains that we have now. So we don't have some sort of hardware advantage in terms of our biological hardware. We do have better tools. David says it was not a lack of trying or a lack of thinking or a lack of observing. People looked at the world, tried to understand it, and got a lot of things wrong. Sometimes they did find some simple patterns, but they often failed to understand what was actually going on. So this is what the world was like, but then science changed things. He goes through also talking about how slow progress was. So from the point of view of an individual, during their lifetime, often nothing changes. If you can go your whole life with nothing changing, then it seems like progress is not being made. So science changed things. How does science work? Well, we're going to go on another tangent. We're going to talk about the Enlightenment. So yeah, another digression. So he says the scientific revolution was part of the Enlightenment, which brought progress in multiple fields. He says all conceptions of the Enlightenment agree that it was a rebellion against intellectual authority in regard to knowledge. Against authority in regard to knowledge. So David uses this phrase here, authority in regard to knowledge. I often call this, for short, intellectual authority. Authority regarding the intellect, regarding knowledge, that kind of thing is what I mean when I say intellectual authorities. That's different than the authority of the courts. Those are legal authorities who get to say that something was legal or illegal and possibly put you in jail. So there's different types of authorities. Intellectual is my word for authorities related to knowledge, learning, ideas. So the Enlightenment was this rebellion against intellectual authority. And David says that all conceptions of the Enlightenment agree on that, which I wanted to highlight because I disagree with that. I'm very confident that there are points of view on the Enlightenment that see it in a different way. I think there would be ones that deny that it's a rebellion, and certainly that it was a rebellion specifically against intellectual authority. That's an interpretation of history that I'm sure many thinkers have disagreed with. I've talked with people about the Enlightenment, and they didn't all say to me, oh yeah, that rebellion against intellectual authority. Their points of view vary dramatically, like they often just focus on different things entirely. So that's a minor point. But it would be better if it said, some conceptions. So David goes on to say, people used to believe that everything important and knowable was already known. That's what he's trying to explain in this next part. And it's related to their not noticing progress happening because it was so infrequent. And so they thought that knowledge had already been discovered and was enshrined in authorities, such as ancient writings or traditional assumptions. But, David says, these authorities had lots of falsehoods and dogmas and errors, including as well as some actual good ideas. So there's knowledge mixed with lots and lots of error. And therefore, to make progress, it was important to be able to challenge the authorities so you could reject some of the errors. So, there's a motto, take no one's word for it. However, David points out, rebellion against authority can't be the key to science because it's been tried many times before and often not worked out very well. So what's needed is what David calls a tradition of criticism. He says usually traditions are about keeping things the same, but a critical tradition is one in which people are trying to improve things and have some sort of continuity over time, but you're allowed to question things and challenge things and try to make it better. So, for example, physics has criticism over time. People have come up with better and better theories of physics over time while staying in the same tradition. It's still physics. They're not like, fuck physics, I'm going to make something completely different. They're like, I want to build on it and make it better and change it for the better. And they're also not just trying to preserve it. I mean, some people try to preserve it. Not everyone's reasonable or helpful, but some people have tried to make it better. So some people are trying not to rely on authority, and that was helpful. And then the next point David talks about is testability. So the ability to do scientific experiments to test something, to try to check is it right or wrong, or to distinguish between contrary claims. That is a hallmark of science that's gotten a lot of attention in recent years, and I think in the past as well. People noticed that there was something important there. Yeah, Galileo talked about it. About experimental tests where you're trying to check, does this actually hold up? Can we specifically try to see if we were wrong? Not just observing nature out there, not just observing what's available to observe conveniently, but setting up a specific observation on purpose that we think has a chance of teaching us something that we are wrong, or that there's something interesting or new there. So testability means, could this theory be refuted by observation? Is there a test we could do? Is there an experiment we could do that would show this was wrong if it's wrong? So that is a helpful part of science. It helps us keep our ideas connected to reality, because if we're contradicting reality, then there would be a test that could show that. We said this about reality, but we could set up a test experiment where we see what reality is actually like and see that it's something different. However, testability is not enough. Many ideas have been testable and still been unscientific, not very good. Like a gambler who has a hunch, this is my lucky night, I can feel it. That is testable. You can go gamble and lose a lot of money and then find out, oh, I was mistaken. The experiment has shown that it was not my lucky night. Nevertheless, that's not science. It's not productive. It's not how people learn things. So to recap, what we talked about today, observation is indirect, and it involves fallible interpretations. The Enlightenment rejected intellectual authority. Testability is important to science. And we're talking about how do we know stuff, and the answer is still coming up later. And I wanted to go through the book so far. What are the things we've talked about? Unbounded progress comes from good explanations, knowledge, learning, that kind of stuff. That was the introduction. And then in chapter 1, we've talked about empiricism, induction, justificationism, and intellectual authority being errors. We talked about fallibility, and that observation involves fallible interpretations. And science brought progress on the timescale of one lifetime. We've talked a bit about the Enlightenment and about scientific tests and testability. So that's where we are. And that brings us to page 14 in the hardback book. We're still in chapter 1. I think we're a little under halfway through chapter 1. So if you like this, sign up for my free email newsletter to get notifications about new things I make, because I make a bunch of other things besides YouTube videos. And that's at fallibleideas.com/newsletter, or just go to Fallible Ideas and then near the top, click on newsletter. And also like and subscribe, because more parts are coming. I will keep going through at least the end of chapter 1 is my plan.